Welcome everyone, my name's Mark. I am the co-facilitator of TeachMePCB along with Jesse Robinson, and today I'm going to go over the basics of laying out a land pattern, something that you have to do in your parts editor. Now, I'm pretty much the only person on planet Earth other than the developers that uses dip trace. So the exact button clicks aren't going to be useful to you. And that might actually be useful. You won't be able to follow along. You're going to have to interpret and understand what I'm doing and then take that knowledge and go back and apply it to your EDA program. Right? You can't copy along. You've got to do it yourself. Anyhow, we're going to go over the Raspberry Pi Pico today. And let me get that on an overhead cam for you. It's this little guy right here, and our job is to come up with a matching land pattern that will intercept all of these pads so that when we secure it down to our board, we've got something to solder it to, right? That's what we're doing. Your part editor is going to be responsible for your pads, for your silk screen, for some invisible layers, and we should probably start with those. So let's go to a picture-in-picture view. All right, now I just have to stay on screen. So the first thing that we probably want to talk about, and I can just zoom out, let's do that, is what these various layers are. One layer is quite obviously the copper. Some parts, especially through-hole parts, they actually pass through your board. So you'll have another layer on the bottom. And each of these are copper layers. Everything that I'm going to draw, everything that exists on top also exists on bottom, right? So I'm not going to draw all of the layers that happen below, but there is the exact same thing happening on top of the board that happens on the bottom of the board. It just passes through the mid layer. So we've got a top copper layer. On top of the copper, we've got a solder mask layer. This is the colored stuff that you see, but it acts like a solder dam. It protects your board, and it keeps the solder from flowing all over the place. So this is your LPI, liquid photo imageable solder mask layer. Then we've got a layer. There's a straight edge, would have come in handy with when we started this little adventure. So then we've got a layer on top of that. That is your silk screen. It can be all sorts of different colors, but this is the layer that you would put R1, R2. You would put a pin number perhaps, or a net name. So this actually gets fabricated, this gets fabricated, this gets fabricated, right? Manufacturers actually go through processes to make those. But there's other layers that they don't make. Well, they use them, but they don't turn into actual physical things. One such layer is something called a courtyard. Is that going to be visible on screen? Kinda. This pin has seen better days, but it works kinda. So the courtyard layer is just kind of a keep out. When you have a part, for example, that Pico that I've already seemed to have lost. Wow, that was actually really impressive time-wise for me. Lose something that quick. Well, if you've got the Pico, you don't want to put other parts too near it. So the courtyard is just a contour that goes around your part. So that you don't put other parts too close to it. So it's just a contour. And you'll notice I did a big area out here. You're going to need to be able to plug this thing in. And cables usually aren't all that bendy. So you need an area out in front. You might even need to put this thing at the edge of the board so that you can plug into it that way, because it's going to sit really close to the edge. Anyhow, that's your courtyard layer. Then on top of that, you've got an assembly layer. Your assembly layer is going to be used by the fab house for the pick and place, for locating the center of the part, the centroid or the number 1 pin, depending, and helping to pick stuff up and place it where it needs to go. There's a few others too, and in fact I can bring them up for you. I think I'm on screen almost. Oh yeah, I just need to change this. Give me a second here. And let's bring up dip trace. There we go. Wrong screen. No! Yeah, that's going to make it mad. Let me close these. Sorry. I thought I had it ready to go, but when you're working off multiple screens, sometimes things just don't work the way you want them to. No, I don't want it on that screen. Yeah. Not ideal. Dip trace doesn't like moving from 4K to 1080i. Come on. There we go. No, come on. There we go. And it messes up this toolbar, which kind of makes it hard to see things. But those are just some of the various layers that you see, and they're reflected along the bottom too. There's going to be layers for board cutouts. There's going to be layers for mounting holes. Layers for dimensions. All of these layers are things that you have to draw. A lot of fun. We're going to do it together. It won't be too bad, but let's flip back over and take a look at our pattern first. Let's see if we have... There we go. Now, the Raspberry Pi Pico datasheet angers me. It makes my eyes rain. I don't like it. I don't find it terribly clear. It's workable. It's just not ideal. For example, the dimension at the top left, 49.86, is measured from top pad to bottom pad. There happen to be 20 pads. You have to count that. 46.66 is from the inside of the top pad to the inside of the bottom pad. So if we subtract those two numbers, what we'll have is the height of two pads. The probably best way to illustrate that right when we subtract them, we're going to get the height of two pads. 46.66 to 44.78. So that's from the inside of pad 1 to the inside of pad 20. 44.78 is from the outside of pad 2 to the inside of pad 19. Clear as mud, isn't it? So that will give me the spacing between two pads. All right, we're going to run those, even though we can very clearly do those in our head. 3.2 isn't hard to come up with. We're going to run them through the calculator just to make sure that we don't do something stupid in the subtraction process. So we've got 3.2 divided by 2. So I've got 1.6 for the width of one of these pads. As far as going on the other side, we're going to do the same thing. 46.66, 44.78, subtract them, divide by 2, and, oh, I guess I should write it down first, 1.88, divide by 2, so what we've got is a single pad plus the space to the next pad is 1.6 plus 0.94. So the distance that we need to go from pad to pad the interpad distance then is 2.54 millimeters. Now, next up, we've got to figure out the width of these things. And for those, I need the 22.58 and the 16.18 measurements that are down at the bottom here. 22.58, 16.18. Subtract them, divide by 2, and we get a pad is 3.2 from end to end. All right, we are ready to type some things into our calculators there. My standard pad is going to be D-shaped. It's got a width of, we said, what did we say, 1.6. A height, or I'm sorry, let's do a width of 3.2, 1.6. And let's just kind of see what that ends up looking like. If we got it right, nope, I got it backwards. So let's back that off. I figured I did. I wasn't quite sure. Let's see what that looks like. That looks like the pad I was expecting. Okay. Now, we're going to go and make an array of pads down one side and then up the other, and then we're going to set the spacing for them. That's great, except are there 20? I better double check. 3, 4. There are, in fact, 20. So down one side, up the other. Oh, I don't know if they're straight. They sure don't look straight. Let's make sure we've got a grid snap on. That's what's wrong. So I'm going to snap to grid, and I've got my grid set at 2.54 millimeters. So these things are going to all pop out at 2.54 millimeters spacing distance, which is what we want. And then I will fix my origin and all of that in a minute. I just want to get these things down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 through 20, 21 through 40. I'm not doing that arbitrarily. I am doing that based on the data sheet, the Pico module. So if we scroll down to, looks like I might have already made comments on it. Let's come back here. If it'll let me, will it? It won't. Okay. I can't tell yet if those are, well, that gives it to us anyway. I just need to zoom in some more. Or maybe that's my max zoom. Okay, so it goes 1 through 20 down the bottom, 21 through 40 up the side. That is indeed what we want. Now, spacing. If I go back to the image here, I either need 16.18 from inside to inside or 22.58 from outside to outside. So I'm going to pull up a dimension tool and capture inside to inside. Whoops. Okay, I need that to be 16.18. Right now it's 14.58. And I don't have it. What I'm going to do then is set my grid nudge to 0.1. Grab all of those. Whoops, 16.18. So now these things are exactly where they need to be, right? I do want that dimension, but I'm going to move it down here where it's a little closer to what it looks like in the data sheet. Okay, and then 22.58. Whoop. Highlight, select. Okay, those are done. And while I'm at it, I'm going to add a couple vertical dimensions just to make sure that I got everything here correct. I can't tell if that's letting me highlight it or not. No, that's off. Will it let me do it? I thought it dip trace would do it. Well, let's just try it. But I'm pretty sure it's grabbing grid coordinates instead of the part coordinates. Let's see what number we get. 49.9. It's supposed to be 49.86. How else can we do this? View. Well, tell you what, let's not worry about it right now. But I would like to come back in and add those additional dimensions just so that we can keep track of anything. Next, I've got to edit these radii. If we go back to the data sheet, ground, 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 ground. Mirror image on the other side. So those are different pads. I'm going to go back and I'm going to edit those to reflect that. And the way that I do that on dip trace is I no longer use the standard pattern dimensions. I'm going to do a rectangle with a rollover of 0.2. I can't read that. I think that says 0.2. It's just mad because of what I did. Now the next question is, can I do multiple pads at once? Let's find out. We're going to turn that off. We're going to turn these to rectangle, and 12.5 gives me the specified rollover. Oh, I can. Okay. So then let's just grab the rest of them. I need 4, 5, 4, 5, 6, 7. I need pads 8, 9, 10, 11, 13, 18, 20, 23, 28, 33, 38. So grab 13 and 28, 8 and 33, and 38 is left to do. Width, height, all of that business, 12.5. Okay. We're looking good so far. So now the question is, what are we going to save this as? This is my library. This is going to be the Pico module. It'll be fine in there like that. We still have to get the pads up in here and the 3 pads down here. I'm going to do the lower ones first, despite the fact that I'm sure they're going to anger me. So these are going to be pads 41 through 43, and this is silly. So probably need to get in even closer for you. So they've created a datum, a little point right there that things are measured against. From pad number 20, the bottom of pad number 20, that datum is 0.57 below that. And below that datum, another 0.8 is the bottom of these pads. So 0.8 plus 0.57, so we've got 1.37 is the bottom of this pad below the bottom of this pad. Raspberry Foundation, if you're watching, I don't like the way you did this data sheet. So we need to grab that. And we need to grab that. Oh, did it? And we are going to have to move these things so that they are 1.37. Now my spacing isn't sufficient, so I'm going to drop that even more. Whoops. No, 0.05. Enter. Grab those three and move them down to there. All right, that gets me that. But now I need these things to be 6.68 apart. I bet you they are already there, but we're going to measure them to find out. They sure are. And then 16.18 center to center. That does me no good. Oh, I already know that. I need these things to be centered with respect to each other here. Okay, so those are not centered. So we're going to grab those and they are now centered. All right. This is one of my magic pads again. So give me a rectangle with 12.5 rollover. No. I had them all selected. My bad. Give me a rectangle with 12.5. Okay, now we're starting to look like something useful. Not a ginormous fan of the data sheet, but at least we are making forward progress. Now, they created a datum right there. Let's put in a filled obround on the assembly, and then we'll locate it manually here in just a second and move our origin there. Yeah, I don't care about that. And we'll just make it 1 by 1. Yeah, that's fine. I don't really care. What matters is where it's located with respect to the left of that pad and to the bottom of that pad. I need the center of that. Is it not going to let me? There it goes. And then I need another from there to the center. Okay. We've got something. According to the data sheet, it needs to be 0.79 from the left edge. That's close, but not close enough. We'll get that in a second. And it needs to be 0.57 down. So we're going to drop this down to 0.01. Give me a smaller nudge. There we go. So this is going to become the new 0, 0 on my design. Why that's the 0, 0, I couldn't tell you. But from that datum, they've laid out these last 3 pads. And these last 3 are the USB D+, D-, and ground. they are not going to be that size. So the first thing well, here, let me just turn off the, there we go, just so I can edit those without screwing up everything. And it gives in the dimensions that the top two are 1.8 tall and 1.1 wide. And they are browns. Well, except it needs to go the other way. And then it says radius of 0.55. Let's get them both at once. Yeah, it looks pretty much the same to me, but whatever. And then finally, (1.45 times 1.05). Why they're so different, I couldn't tell you. And radius 0.525. Oh, but that's not a percentage, isn't? Haha. Whoops. There we go. Now, as far as location goes, the datasheet is actually kind enough to locate these for us. So the 9.5, 49.8, 11.5, 49.8, and 10.5, 46.5, we're just going to put those right in because they're referenced from that datum that we created a little bit ago. So I just go over and start typing in. $49.8. $11.5, 49.8. And finally, 10.5, 46.5. Okay, those are located. There's only one issue. This is the surface mount design. If you guys were going to put this down in a reflow oven, this is just fine. But if you're not using a reflow oven, you need a way to get in there and apply solder and heat those spots. That's tough to do. So instead of leaving those the way they are, I'm actually going to change those from what's recommended and make those through-hole parts. And we will just, they can be op-round, I don't really care. But what we need to do is put a hole in the middle. Through-hole part, yeah, let's just see what that looks like. There we go. So now we've got some holes in the middle. The only thing is that these things don't have very large annular rings. The spacing, the copper around the edges there isn't that big, and that can cause some errors. So what we're going to do here is grab those, and we're going to see if we can't either shrink those holes. Those are pretty big diameter holes. I could take those down to 20s. And then I'm going to see if I can't make the so if we do 20, let's call that 60 and 60. Let's see what that looks like. And we need to know the spacing between those two and make sure that is going to not throw an error. So I've got 20 mils between them. I mean, that should theoretically work. It's not going to be the prettiest joint ever, but it'll hold. There's space in the middle. There's space there's an annular ring that's big enough. The space between them's big enough. So that should theoretically work. I'll leave those off. Now, we're not done. Let's go to a reasonable... Yeah, 25 mils should be fine. A reasonable grid size, and let's put out our courtyard. This is going to be our keep out area. And these can be relocated after. You can move them around a little. I just kind of want to get the basic idea down. I want to give a decent space around the top there. Whoops, haha. What can I say? So just bring that one down. I couldn't bring the other one up, and then that side's too high too, and it's at an angle, and blah blah blah. But all of that is adjustable. Oh, and if you look, I messed up these. I turned them all into vias when I was playing around with the others. So I've got to click on all of these and make them surface mount again. Whoops. I tell you, I just can't have nice things, can I? Keep breaking them. It's the only problem with using standard pad properties in DipTrace is it's very easy to mess things up when you don't mean to. Surface D-shape. There we go. That fixes it. Okay. Now, you also should get in the habit of putting a pin 1 indicator. And that can be a circle or a triangle. So I'm going to put one in my assembly layer. That won't show up on your board at all. And then I'm also going to put one on my silk. That will show up on your board. It's right now hiding underneath the assembly layer, but it's there. Right? And then you can add other information if you want. You don't have to, but you certainly can. One thing you might consider doing is, instead of doing this big offset thing that I did here, you could indicate that this needs to be placed next to the board edge. I'm going to delete points here. Just because anywhere you put it on the board, it is going to end up really close to the board. That could be problematic later on if your off-board USB doesn't work. So I'm just going to get that party started. And then we will label that board edge. No, come on. Don't be that way. What's going on, DipTrace? There we go. It took it that time. Yeah. courtyard, anchor point, font settings. This will never print, so I can go to any size and it'll be fine. But this reminds me that when I place this, that needs to go towards the board edge so I can always plug in my USB. All right, so let's save that as the Pico. Module ref_dense is going to be U whatever. Okay, and then we can save that. Now, we're not done. We need a 3D model. Oh no, don't be this way. It's going to be completely off screen. Am I not going to be able to show you how to add that? Oh, come on. Oh no. Okay, let me bring this down to the other window and see if I can get that opened up and then move it back. I don't know if I can. It is off screen on this one too. Well, foo! Okay. Do I have any other tricks up my sleeve? Can I edit 3D model from here? Nope, still off screen. Well, phooey phooey. Yeah, it's way off screen. Okay, so at that point, you can go out, once you have that basic idea, and find a Raspberry Pi 3D model. No. From a variety of sources, and import one that is appropriate for your EDA program. I mean, this one looks really well done. I don't know if it is or not, but we're going to find out. So I would download that and actually compare it to the pads in the program. Let's try that. Select an annotation. How about save? Is save an annotation? There's also one, the Raspberry Pi Foundation has one too. So there's no need to pay for any of this. I just don't see a download. Maybe I have to log in or something. But anyways, there's plenty of versions of this thing around, and you can actually take them and import them into your 3D program or into your EDA program and compare, which I can't do because all of the important buttons are way off screen, but you can actually compare the pattern that you just made to the 3D model and see if everything lines up. If it does, you're golden, you're good to go. If it doesn't, you have to figure out, is the 3D model bad or is what you did bad? So anyhow, that was unpleasant. I don't know. Let me turn off my picture-in-picture here. Now, what I did do for you, because I am not a big fan of this, right? That doesn't make, what's the phrase? It does not spark joy. That does not spark joy. So I went through and I indexed everything off the pin number 20 there so that you can have a little bit of a better time figuring out where parts are. And that will be part of the resources that are available to you when you lay out your patterns next week. Now, that's not the only thing you have to do. If you did that for every part that you have, it would be a long week. Personally, that is what I do. I've been burned far too many times importing other people's models. But it is possible to grab those things from places like Snap EDA. So let me take a quick moment and show you how to do that. Hopefully it'll be on screen. No, it's off screen. Don't be that way. The only other thing we can do is I wonder if we can close it and reopen it. In the wrong screen. Gear. I wonder if we can project. I wonder if I just change the resolution. Yeah, duplicate. I want it to be duplicated. I'd prefer it wasn't. But it's not duplicated, it's extended. Something's wrong. Oh, this is frustrating. What else can I do? Wonder if I can. Oh, here we go. All right. So, it's not ideal, but I can kind of make it work. So you type in the part that you're looking for. You do have to create an account, which I'm not going to do right now. But you can absolutely download whatever it is part that you're looking for, right? If a pattern exists, absolutely go ahead and download it into your program. And also grab the 3D model if they have it and link it to it. Anyhow, once you get those, you still need to use the dimension tools to figure out if... I guess I should go back so you can see me again. You still need to use the dimension tools to figure out if the part is accurate. It might not be. But that can save you a ton of time when you create your library. All right. That is the brief overview of everything in the world and then some. But that is the basic idea. Put down your pads. Put down a courtyard. You can add silkscreen for the pin 1 indication for any parts that are potentially ambiguous, but you should put it down anyway because it'll sometimes throw holds at assembly houses. Even if you hand assemble, get in the habit now. Indicate pin 1. And once you have your pattern library, next week we're going to go through and we're going to make components, these little schematic symbols, and link all of the pins and the symbols to all of the pads on your part. Then we get to capture the schematic. Then we get to lay out our boards, order them. You know, we'll do some double checking along the way, but we'll order them and we'll be off to the races, off to the party. We're getting there. As you go through this, you might start thinking, man, this is tedious. It is at first. It certainly is. You're learning. Learning's a little slower than doing. But once you learn, you're going to get faster. And once you have parts in your library that you know are going to work, you don't need to go make those again. You just keep building your library and adding to it and making stuff bigger and better. So with that, kids, it has been fun. It's been probably like an hour. It's been a little while. So it's hopefully good. You can also hit me up during office hours. You can hit me up during class. Discord seems to be very popular. We've also got the forums. So post stuff, add it in, and we'll get going. Appreciate your time. I'm Mark for TeachMePCB. Our sponsors include Walkwe, the Analog.io, Advanced Assembly, Royal Circuit Solutions, Keysight Technologies, Altium, and who knows who else. I could be missing some. Take care. Bye.